Welcome back. Now that you're all inspired to create your moon rocket with a robot arm that can see whether or not your houseplant needs to be watered, let's find out the next step on your Arduino physical computing journey. In this hands-on stage, you're going to learn how to use an LED, which is not on the Arduino Uno board, and how to use a breadboard and jumpers to connect all the pieces together. Then at the end of the section, you'll also learn how to use a button to send input to your Arduino so you can respond to the physical world. So, you are going to be using some external components, that is, components that aren't on the board, so let's take a look at what you're going to need. First of all, once again, you're going to need your Arduino Uno and your breadboard. This time you'll also want to have some jumpers and an LED. So the LED on the board is a surface mount LED, so that means that it's a lot smaller than one of these through-hole LEDs. But they use the same technology, and this one happens to be red. And then you'll need your USB cable, and finally you'll also need one of these resistors. They have two red lines at the beginning. You should be able to find it in your kit, and we'll talk about how you actually identify resistors when we get to needing them. The way that we're going to use the external LED is shown in this slide here, where you have the LED that is connected to ground, and then a resistor, and then to pin 13. Now, you can actually get away with not including a resistor in this circuit, but it helps protect both the Arduino and the LED. So it's a good habit to get into using it. So you might be asking, well, what's an LED? So the LED, which you can see here, is generally a device that can emit light from this point in here, and then has a coloured shell around it to provide it with colour and help the light diffuse. Now, you'll notice some features of the LED. One is that one leg is shorter than the other, and the other is that there is a flat section on the side of the LED. You can see that more clearly in this slide. Now, the important thing about the LEDs is that there's a correct way for them to go into the circuit, and there's an incorrect way for them to go into the circuit. And that's what the shorter leg or the flat slide helps you to tell which way it goes in. So the longer leg goes towards the positive side of the circuit, and then the shorter leg goes towards the ground. I could never remember which way goes which for quite a long time, but eventually I worked out that I'm not really that keen on animals, and so I'm kind of negative about cats, and that helps me remember that the negative side, or the cathode, which is the flat side, goes towards ground. You may choose to come up with another way to remember if you like cats. So the next component that we will need is a resistor. So if you've got the kit, you can separate one resistor out. Now, because resistors are small, they can't have the value or the amount of resistance that they provide printed on them. So instead they have this color code. And each band of the resistor color code means a different thing. So the first two lines give you an idea of the value. The next one is a multiplier, so that gives you an example of the magnitude of how much resistance it provides. And then the last band shows how accurate that value is. So a cheaper resistor might be sort of anywhere plus or minus 10% or 20% of the actual value that you're looking for, but in most cases it doesn't actually matter. If you're using a resistor in a situation where it's really important to have an accurate value, then you can get more expensive resistors which have a smaller percentage of tolerance. Now you might be thinking, oh, well, how do I know which colors mean which numbers? Well, there's a helpful resistor color code, which you can learn, and there's ways of memorizing all of that as well. But don't worry, you won't have to, because we also have a thing called the internet, and there's resistor color calculators that you can find online that will say, if I have this color resistor band, what value resistor is it? Or the other way around, you can say, I need a resistor of a particular value. How do I know what it is? So in this case, we need a 220 ohm resistor, and that's what works with this red LED. Different colors of LEDs require different sizes of resistor. The other item that we're going to use is our breadboard. As I mentioned before in the intro, your breadboard, if you got one in the starter kit, will be a translucent one, but we're having a white one because it makes it easier for you to see. If you look at the slide, you can see that the way that a breadboard works is that all the holes are connected to each other. And so along the side, they're connected in a column. So on these two pieces here, and then on this side here as well. And then in the middle, they are connected horizontally in rows. And so these are connected together, and these are connected together. But where there's this break in the middle, they're not connected. And the same is true between these and these. So if you put a jumper wire in here and a component in here, those two pieces will be connected. But if you put it here, then it won't be connected to that. So basically, the way that a breadboard works is that underneath the holes there's a little channel, and as the leg of the component or the jumper goes into it, that makes a connection. So for example, if we tried to insert the jumper into here, then we would make a connection there, and then we could say insert a resistor here, and then there would be an electrical connection between those 2 points. So that we know how to put things together, we want to refer back to our circuit. So there's lots of ways that you can describe a circuit. There's a standard way called a schematic, which uses a diagram to show how the components are connected together. But you need to learn to be able to read a schematic. So on a lot of the tutorials on the Arduino site, you'll find a picture diagram instead, which shows you how things are physically connected. So over time, you'll learn how the physical kind of picture diagram relates to a schematic. But you don't need to know that at the moment. But the main thing to keep in mind is that we're talking about circuits. So that means that you need to have a cycle or a circle for the circuit, the electricity to flow through. So that's an important thing to keep in mind when you're troubleshooting, because if you've got a break in the circuit, then it won't work. So let's take a look at how we put this together on our breadboard.